In this last video for Chapter 11, we are going to take a look at hypothesis testing for two sample proportions. Again, here is our summary sheet that has everything that we need to know. First, the conditions for a binomial distribution must be met, which means a set number of independent trials and its success-fail. And then n p hat 1, n1 p hat 1 is greater than or equal to 10, and then essentially 1 minus p hat times n1, and then n2 times p hat 2, and n2 times 1 minus p hat 2. All have to be greater than or equal to 10. And then we're going to, of course, state the null and alternative hypotheses. Remember, with proportions, we're always using the normal model. And then we're going to find our test statistic. Again, normal model means it's a z-score. And just as we did previously with means, the first one will be the actual difference between our sample proportions. And the second will be the hypothesized difference. And then something a little bit new here, we are going to use something called P bar. And P bar essentially is how many successes out of how many total. And so again, we're saying x1 plus x2 being the number of successes divided by n1 plus n2, which is the total number of trials. And so we're going to take p bar, 1 minus p bar, and then 1 over n1 plus 1 over n2, and we're taking the square root of the whole thing. So again, don't let any of the formulas scare you, because we're just going to let Excel do all of the work. So as long as we know that this is the formula, and we know what each of those things are, we know where to tell Excel to find the information. Everything else is the same as it has been. We'll find a critical value, a p-value, and then we'll reject or fail to reject based on the same criteria. So here's our first question. The mayor's chief of staff thinks that a local newspaper article has changed the community's opinion about the mayor. To test his theory, he finds a poll of the mayor's approval rating that was taken before the article came out and compares it to the mayor's approval rating after the article. Before the article, so that's going to be P1, 480, so for 1, we're going to say X is 480 out of a simple random sample excuse me, of 1,200 voters. And then, of course, P hat 1 would be whatever 480 divided by 1,200 is. And then after the article, which we're going to say is 2, 550, x2 is 550, out of n2, 1180, whoops, 1180, and then p hat 2 is going to be whatever 550 divided by 1180 is. And then based on the data, use a 5% level of significance to test the chief of staff's claim that the mayor's approval rating has increased. So again, that tells us that the null hypothesis is that P1 minus P2 is equal to 0, or remember, P1 is equal to P2. So essentially we're saying we think that they're going to be exactly the same. And then the alternative says, is it in fact true that the first proportion is less than the second proportion? And why did I use less than, considering this says as has increased? Remember, this is after the article. And so we're asking, after the article, is this number bigger than this number? So you have to be careful when you're drawing or when you're writing your hypotheses so that you know exactly what it is you're trying to test. So again, the first thing to do is to check conditions, and the conditions for a binomial distribution are met because there are a set number of independent trials and it is success-fail. And then again, I encourage you to use Excel to do this part for you, to find n1 times p hat 1 and n1 times q hat 1. And remember, q hat is just 1 minus p hat. Notice in the summary, I went ahead and found those two p hat values. which again, this one was 480 divided by 1200. And this one was found by taking 550 divided by 1180. The null and alternative hypotheses we have talked about already. Remember, we think that P2 is going to be bigger because we're saying did the level increase? Is it greater than? Again, this step is really all about using your calculator or using Excel. I encourage you not to try to do a lot of this by hand, just because, again, it's easy to make a mistake. So the first thing we need to find is P bar. That's that new thing that we haven't done before. So P bar is just taking x1 plus x2 and then dividing it by n1 plus n2. And so essentially it's saying, what is the percent success total? So what is the proportion of success for both samples put together? And why do we need that? Because we're going to plug it in right here, and then we're going to take 1 minus that value. Those are two values in our denominator. So our numerator, again, is p hat 1, so 0.4 minus 0.4661. And then the hypothesized difference is 0. Again, because we think P1 and P2 are going to be equal, therefore P1 minus P2 would be equal to 0. That's our hypothesized difference. Again, we're using P bar, 1 minus P bar, and then 1 over N1 plus 1 over N2. Don't try to find a lot of values and round in the middle of calculations. That's why I'm stressing to use Excel, so that you don't round in the middle, because you should end up with negative 3.254. Same critical value that we've always used, same p-value that we've always used. So my critical value is based on a left-tailed test, and when alpha is 0.05, that means 0.05 is to the left, and therefore negative 1.645, norm S inverse of alpha. For the p-value, again, for the left side, we're just using norm S dist, and that's going to be of the negative 3.254, which is our z-score, and we end up with a very small p-value of 0.0006. So again, looking at the two ways in which we can reject or fail to reject, I know my critical value is negative 1.645, and anything less than that is in the rejection region, and guess what's less than that? Negative 3.254. So this is clearly a reject. In addition, p is very small. It is much smaller than alpha, which again tells us to reject. So our conclusion is, with p less than alpha, we reject the null hypothesis. And then, of course, we have to say, what does that mean in context? So this indicates there is sufficient evidence at the 0.05 level of significance to support the Chief of Staff's claim that the mayor's approval rating has gone up. Again, where do we get this part? This has everything to do with the alternative hypothesis. If we reject, there's evidence to support this. If we fail to reject, there's not evidence to support that. For our corresponding confidence interval, remember, we're just going to be using that same critical value that we used for the rejection region. The formula, again, always reference your formula sheet if you get confused. This is p hat 1 minus p hat 2 is our point estimate. Plus or minus, this is our critical value. And then this is the square root of p hat 1 q hat 1 over n1 plus p hat 2 q hat 2 over n2. Our interval then is negative 0.099 to negative 0.032. Again, take care when you are talking about what this interval means, because we have to remember what the alternative hypothesis was and what it is we're trying to prove. So, two parts to our conclusion. With a 5% level of significance, we believe that the mayor's approval rating has gone up between 3.2% and 9.9% after the article. Now, before we continue talking about that, a lot of people get confused because this is negative and this is negative. So how would I say it's gone up? Well, if it's gone up, if, remember, I'm taking p hat 1 minus p hat 2, and this guy has increased, then that means I'm going to end up with negative values. So if this guy is bigger, if P2 is bigger, which is my second proportion, then I'm going to end up with negative values. And that's why we know that it has gone up. The second part says, since the hypothesized value of 0 does not fall in our interval, this supports rejecting the null hypothesis. Let's take a look now at how to use Excel to find all of these values for us. So as usual, I want to do as little work as possible. So I'm going to do the work on the front end to set up my Excel spreadsheet correctly. And once I've done so, everything's going to be super easy because Excel is going to do all of the work. So let's talk about how we set this up. All of these values here are my input values. So that's the only thing that I'm going to need to enter for each question that I do. X1, N1, X2, N2, the hypothesized difference, and alpha. Everything else, I'm going to show you how we set it up. First thing is conditions. Actually, no, the first thing is P1 hat and Q1 hat. Remember that P hat is just X1 divided by N1. So that's where I got this, B1 divided by B2, and then 1 minus that value for Q1 hat. Same thing for P2 hat, it's X2 divided by N2, and then 1 minus that for Q2 hat. And then that's how I can check the conditions, because I'm going to take N1, which is obviously up here in B2, and take it times P1. So P hat 1, which is E1. And so I've done that for N1 P1, N1 Q1. I've done this for N2 P2 and N2 Q2. And notice all of those values are greater than or equal to 10, so we're okay. Now for P bar, remember that P bar says take the two x values in the numerator, so x1 plus x2, and divide it by the sum of the N1 and N2 values. So this is B2 and B4, add those together. 1 minus that value for 1 minus P bar, and then of course we're going to find our z-score. I'm going to give that just a little bit more space to keep it consistent with what I've done on the other videos. Now for the z-score, remember the numerator is P hat 1, which is E1, minus P hat 2, minus the hypothesized difference, close the parenthesis. The denominator is the square root of P bar, which is E6, 1 minus P bar, which is E7, and then 1 divided by N1 and plus 1 divided by N2, which is B2 and B4 respectively. So that gives me the same z-score we had found by hand, so we're feeling pretty good. Now let's talk about everything else. This is a normal model, and so we're using a critical value for left-tailed, same as always, norm S inverse of alpha. For right-tailed, norm S inverse of 1 minus alpha, and for two-tailed, norm S inverse of 1 minus alpha over 2. For a left p-value, it's norm S dist of the z-score. For a right hand, it's 1 minus norm S dist of the z-score. And again, for that two-tailed, you can choose if you're going to do the if-then statement or always look at the positive z-score and do 2 times that. So I'm not going to go into that again because, again, I've talked about it in all of the other videos before this. Again, I'm using my if-thens to tell me to reject or fail to reject whether p is less than alpha or not. The point estimate is just p hat 1 minus q p hat 2. So 0.4 minus 0.466, in this case negative 0.0661, etc. The E, or margin of error, remember, is found by taking the critical value, and notice for the one-tailed test, I'm using the positive I2, and for the two-tailed test, I'm using the positive J2. And then the other part is exactly the same. So it's E1 times E2 divided by B2, and that's P hat Q hat divided by N, P hat Q hat divided by N. The intervals are found by taking the point estimate and subtracting E and adding E. So for the one-tailed interval, we're taking, let's see, this is H6, and then we're subtracting H7, and then adding H7. For a two-tailed interval, we are using the same point estimate, but we're using this other margin of error. So going back to our question, this was a one-tailed test, and do all of the values that we found by hand match up with what Excel has found for us? Yes, and yes, and yes, and yes, and yes, and yes, and also yes. Let's do just one more example for two proportions. In September, the annual U.S. Surgeon General's Call to Action was released. It was an initiative aimed at promoting walking and walkable communities. After a campaign push to emphasize the call to action in their area, community leaders were curious to know if the campaign worked. They hoped that the proportion of local adults who could identify walking as a way to promote healthy living was different than that of other communities. So again, different than is going to indicate that whatever our null hypothesis is, the alternative hypothesis is, the null hypothesis is that they were equal, and the alternative hypothesis is that they are not equal, different than. 1 year later, a nationwide study of, so we're going to use 4114 for N1, revealed that 44.8% correctly identified the activity. Now this one's a little bit different, so I'm glad we're going through this one together. Notice they did not give me X1, but they did give me P hat 1, and that is 0.448. The local group found that 121 local adults, so N2 is 121, 65 were able to identify walking, so X2 is given to us, but obviously P hat 2 is not. Now, we already know how to find P hat 2 because we just did it on our last question, but again, we're going to look at this because you will get questions sometimes where you are not given X. Everything else, the only thing that we haven't talked about is the level of significance, so alpha is equal to 0.05. So let's take a look. We have P hat 1, we have X1, and remember, this is how we're going to find X1. So let's do a little bit of algebra. Oh no, not math. So remember, X1 minus N1 is equal to P hat 1. So typically we know X1 and we know N1, but we don't know P hat 1. In this case, they told us P hat 1 was 0.448, and they told us that N1, so X1 over N1 is 4,114. So how do I find X1? Well, hopefully we know enough about algebra to know that I would have to multiply on each side by 4,114, and that would give me X1 on the left side and would give me what appears to be 1843 on the right side. Again, everything else is pretty straightforward. We check the conditions are met, it's a set number of trials, it's success fail, and we can use Excel to find N1 P hat 1 and so forth. Everything is greater than or equal to 10. The null and alternative hypotheses we've already talked about. They're equal or they're not equal. For gathering data, remember we're finding P bar, the test statistic, the critical value, and the p-value. When I'm finding the p-value for a two-tailed test, just keep in mind, if my test statistic is negative, I'm going to find 2 times the probability that z is less than that value. If it's positive, I'm going to take 2 times the probability that z is greater than that value. And that's why things get a little bit tricky when we're doing this in Excel. Before we move on to the next page, let's talk about what I should conclude. Remember, if 1.96 and negative 1.96 define my rejection regions, I'm only going to reject if a value is greater than 1.96 or less than negative 1.96. I have found negative 1.943, which is just slightly greater than negative 1.96. And therefore, this is going to be a fail to reject question. Again, P is just slightly greater than alpha, and that is, again, a fail to reject. So our conclusion, we fail to reject the null hypothesis since P is greater than alpha. This means that at the 0.05 level of significance, the evidence does not sufficiently support the community leader's claim that the proportion of local adults who could identify walking as the U.S. Surgeon General's call to action was different than that of other adults nationwide. All of that last stuff, remember, has everything to do with the alternative hypothesis. Finding a confidence interval that agrees, we're just going to use that critical value that we used with the rejection region. Remember, same exact formula we used before. P hat 1 minus P hat 2 is the point estimate. I find this to be my solution. So negative 0.179 to positive 0.0009. What does it mean? Well, with a 5% level of significance, we believe the proportion of local adults who could identify walking as the U.S. Surgeon General's call to action is between 17.9% less, so remember we're just going to move that decimal, 17.9% less and 0.1% more than those nationwide. Since the hypothesized value of 0 falls on our interval, this supports failing to reject the null hypothesis. Let's look at this exact same question using Excel. And again, I've left one spot blank because I wanted to talk about where to come up with that value. So we are given the P hat in this case. So it's okay for me to go ahead and enter that as P hat. But notice it doesn't do anything for me for my X1 value, and I need to know X1. So I can use Excel to find X1. I can say this is equal to P1 hat times N. So I can find the 1843, and then everything else is done for me. So again, looking at everything that we have found, the z-score, this was a two-tailed test, so the critical value, the p-value, our conclusion to fail to reject, and the two-tailed interval, everything matches up with what we found by hand. Coming up next, we are going to move on to Chapter 12. This is over scatter plots and correlation.